To tell you a little bit about Kooshiar, he studied computer science at Sharif and UC San Diego. He became a data scientist at Netsteer, and he started his own company, Concertboom, which within the first year, he got 30 million users. He has published 6 peer reviews about blockchain technology and cryptocurrency. And cryptography, I apologize. Thank you very much for joining us. We're here till 8:30, so thank you again.
So I first want to thank everybody for coming, and thank Parse Equality for inviting me. And especially thank Korea, because there's a lot of work in logistic of throwing these events. I throw events myself, and I know that, and he worked a lot to put this together. So I'm going to start this presentation by bringing up an analogy about internet. So a lot of people who are into blockchain and cryptocurrency are the people who actually started bringing the internet to consumers in the 1990s. And a lot of them believe that blockchain technology is of order of magnitude of the internet itself. And some people say blockchain is as big as internet. Some people say blockchain is completing the internet. Some people say blockchain is what internet was meant to be, and it never became. So the reason I started with this is not to get you guys excited. Maybe it is halfway there, but mostly because if you don't know anything about internet and ask somebody to explain the internet for you, if you ask 100 people, they're probably giving you 100 different answers, and all of them could be right. So the same thing is true as for blockchain. So there depends on what angle you look at this technology and its applications. You can have like 100 different views. So this is going to be my view mostly. Before we start, so let's go over something. So today what we're talking about is blockchain, which is a name of technology, and then Bitcoin, which is one of the first application, which is a currency. So it's the name of the currency on top of the blockchain technology. And then we are also going to talk about Ethereum, which is the broader and higher level currency, again on top of blockchain. Before getting to Bitcoin, we're going to talk about money and what is money and what is wrong and what are the problems with money today and what can be improved about money. We're going to talk about money, banks, central banks, commercial banks, and then we're going to talk about Bitcoin, the solution to all the problems that money has. This is the first part. And then I'm going to go through the blockchain and how it actually works. And then Ethereum, which is an alternative for Bitcoin. And then we're going to talk about what are the possibilities, what are the other technologies that we can come up with. So what we are not going to do tonight is, so where I announced and Parse announced this first, like I got a lot of messages about like what type of currencies we should buy, and probably like that's like 95% of the messages that I got. And we're not going to talk about specific currencies that you can trade. I mean, I'm very interested in that myself, but this is about the technology, not about the currencies. So this is not what we're doing tonight. So to start, let's say we want to have money. We want to invent the money from beginning. If you think about it, like if you want to have money for trading goods, you need to have two organizations. Someone that prints the money and someone that holds the money. A bank, a commercial bank that holds the money that you can make a deposit, and also someone that prints the money. right? Like, you should think about this for like 10 seconds at least. Like, is there any way that you can have money without somebody printing the money? I mean, if somebody doesn't print the money, you don't have the money. If there is no bank that you can make a deposit, you can have cash, but you cannot purchase a house with cash, right? Because you cannot just carry this much cash. It's just not physically doable, and it's not safe, right? So you need these two entities for the money to work. So let's go through. So this is the main part. We're going through what central banks does, what commercial banks do, and what are the problems with these two entities. So this is so the first question that people ask about Bitcoin is, okay, this is a fake money. You just print money from thin air. This doesn't make any sense. And they ask, can you print money from thin air? And the answer is yes. You can do anything. You can print. You can just print a piece of paper, and if people accept it as money, it's money. And the number one comment everybody makes is, shouldn't the money be backed by gold or some metal or some sort of commodity? And the answer to that question is no. Like, most of the developed countries' currencies, they're not backed by anything. Like, in fact, like, if you Google what I just said, the first link is from Federal Reserve, and you can look it up, and it says from 1934, dollar is not backed by gold anymore. And this is true for almost every developed country. You can look it up. So you can print whatever you want, but the question is, let's say you print this money for like 1 billion of this money. Is it worth anything? And the answer is probably not. Because why should I give you a sandwich if you give me 1 billion of this money, right? This doesn't, nobody else is going to accept this as a currency from you. And I mean, think about it, like, if you print money, like, how can you get people to use a money that you just made up? The only way that this, excuse me? If somebody wants to stop me at any time, just feel free. I'm very, like, I'd rather to have this very interactive. So, so the only way this works is some group of people accept this as a currency, that it has some network.
So sorry for interruption. I heard that this is not going to pass. If you want to switch to this one, then you can walk around, you can do whatever you want. Just get rid of that, because it's got a background noise. You can put it there, or you can hold it, whatever it's easier for you.
1, 2, 3.
Yeah,
1, 2, 1, 2, 3. Okay.
Sorry.
So this is a very important start for this discussion, and you have to think about this concept. So the only way that this money, if you print 1 billion of this money, or anything, is when people start using it. What's the only reason that people start using your money? The only reason that people might start using this money is this money has some certain property that works better than dollar. And it's very hard to imagine such a scenario that the money is better than some other money, because this is just a piece of paper. So we're going to this slide. This is actually very interesting. If you Google Zimbabwe inflation, you're going to see a lot of these pictures. So this is a kid probably going to buy a cookie or something with all this money, and they're like, internet is full of these pictures. So Zimbabwe had the monthly inflation rate of that number only in 1 month. So the reason I brought this up is to see, like, when you give authority to one entity to print money, and without your knowledge, they can print money at any time without the consensus of public, like, a lot of weird things can happen. And to just get a sense of how big is this number, if you sold the company for this amount, 790 million, and you go for a trip for a month and come back, like before leaving the, this is better. So you have $796 million. You can buy that mansion and you still have most of your money left. If you left the country for a month and come back, you cannot get a taco. That's how much inflation they had in 1 month. And it's really funny, actually. So a lot of people say, okay, that's a country that probably they didn't have a good central bank. But if you look at it, I mean, in US, your money has been deflated 6.31 in last 47 years, which is not necessarily a bad thing. I'm not saying this is a bad thing, but the fact that we don't know how this changed, that's a bad thing. There's no formula behind it. Like, you don't know what's going to happen next 40 years. So this was about central bank and why printing money, why having one central organization that can print money, what kind of problem you can have without any mathematical rules behind it. So let's move to the second part of the money, which is commercial banks. The like usual banks, Bank of America, Wells Fargo, all the banks that you deposit your money. So what is the function of a bank? The main function of a bank is very simple. So what's the main thing that you expect the bank to do for you when you deposit your money? You want the bank to hold your money, and when you want to buy an item, you start your debit card, and if you buy a sandwich for $10, they subtract 10 from your account, and then they show you the new number, right? And they add $10 to the person who sold you the sandwich, right? That's the simplest and number one reason that you need a bank. The thing is, keeping this ledger, keeping this database of all the transaction was a very hard thing to do 40 years ago, right? Without all the technology that we have. But today, probably you can keep track of all the transactions. If you look at it, like there are 100 million people, and if you keep like 1 kilobyte of data per person, all the numbers, all the transactions, or maybe the amount of money that they have, you can track that in just one laptop, right? And you probably can run this operation with a few $1,000s a month. So why are the banks are so big? If the main function that they do, you can do it in one laptop, why are they so big? And what's the value of the bank? So one question is, let's say if this is as easy as I said, I have a laptop and I start keeping track of all your transactions. Are you going to deposit your money to me? The answer is no, because you don't trust me. I can just run away with your money. And the bigger picture is we're paying the bank because we trust them. So that's what we're buying from the bank. And this is like a very simple example. Like if there are 2 banks in your city and they are offering the exact same rate and exact same everything, but you see these 2 buildings, which one are you going to deposit your money to? Right? Almost everybody is giving the money to the one in the right because just the building is bigger. And you assume that because they have a bigger building, you can trust them more. But if you think about it, you're paying for that building. And that's very ridiculous, right? So you're paying the bank so you can trust them more. So So these are the few first issues. The other issues we have with the banking, which is a very big issue. This is the map of unbanked population of the world. So if you look at it, we have countries that 80% of the adult population doesn't even have banking. So the reason they don't have banking is it shows that banking is expensive. Running that operation is expensive, is not as profitable as you might think. And the reason is it's that expensive is not because the software and the database, that part is expensive. It's because gaining that trust is an expensive process. So that's the unbanked population, and then the fourth issue is the microtransactions, right? So if you think about, we still cannot process microtransactions. Still don't make sense even on the internet, right? If you want to transfer 1 cent to a friend for any reason, that doesn't make any sense because you have to pay 30 cents processing fee. And some people ask why, you want to send 1 cent to somebody. The answer is we don't need. The thing is, if we have microtransaction, we're going to have a lot of new applications that could change every industry. For example, if you look at the publishing and the video content industry, the reason we see ads on every video, the number one reason is because we don't have microtransaction. You cannot pay the guy. If you really like the video, you might want to pay the guy 1 cent instead of watching ads every 5 minutes, right? But because there is no microtransactions on the internet, we have to watch the ads. If we have microtransactions, a lot of, especially internet industries, can change. So I go through the problems one more time. So we have the trust in bank. That's so the trust in central bank. So again, I want to emphasize that I'm not trying to say banks, central banks are bad people or they're corrupt people or any of these things. I'm not trying to say commercial banks are bad people. What I'm trying to say is this architecture that you put a few people in charge of everybody else's money, this decentralized model has issues. And the main issue is that's the main problem. You're trusting a few people that you never met, you don't know how they're going to work, in charge of the entire power of the world. That's the main problem there is. And then, if you look at it, maybe you're okay with US central bank, or as we call it, Fed. But what if you want to do trade with the country, then you have no idea about their central bank, right? If you want to start trading with that country, you have to trust their central. Some people say, okay, you can take their money and exchange it to dollar, but you're paying a transaction fee again for that exchange. So there are a lot of frictions, and that put a lot of people out of the economic cycle of the world. It's a huge issue with the globalization. So trust in central bank, trust in commercial bank, trust in other central banks, accessibility, microtransactions, transaction, and then the security vulnerability. That's the main issue. If you have a centralized model, the biggest problem is centralized model is there's one point of attack, and if you attack the Bank of America's headquarters, main computer, whatever it is, you have access to all the accounts, and you can, if you hack one main server, you hack the entire system, and you have control of everything. That's the biggest problem. So let's see what's the alternative. How can we change this? If the banking is as easy as keeping track of how much money everybody has, and just this simple arithmetic that if someone deposits $100, you add 100 to their name. If you spend $100, we subtract that. If it's that easy, you can just run it on a laptop, right? So before going forward, I introduced a concept called wallet. Well, you can think of wallet as a mailbox or as an email, right? So let's say every person in the world has multiple wallets. It's like multiple email accounts, and they have an address. And you can, if you have wallet, so wallet address is public. You can send money to everybody you want. But in order to open a wallet and take money out of it, you need to be owner. You need to have the password or private key for that wallet. So this is kind of the only main difference for people who are who want to get more technical. Wallet has the entire software. So because we're entering the decentralized model, there's no server, so everything is in the wallet. So let's start thinking about the alternative to the banking system and centralized model. So in the centralized model, I mean, there's a server, there's a manager, there's a center that has all the data, and they make sure that they make sure the integrity of the data is okay. They make sure all the transaction goes through, all the transactions are valid. If you want to get rid of the bank, which is very crazy, just let's think about it for like next 5 years. So just think about it. If you want to get rid of the banks, what happens? Let's say we get rid of the center, we get rid of the banks, and we ask people to send the money. Let's say every time you want to pay somebody $10, you send a message to her wallet, the number 10. Right? So how can we, so if you do that and you subtract 10 from your account and you add, and she adds 10 to her own account, and we assume that you're both, you don't want to commit fraud at the beginning, right? So you just want to send a message of 10 to that person. Is that going to go, what's the problem with that? Let's say everybody becomes, everybody keeps the entire database that a bank usually maintains of all the ledgers of everybody, all the money that everybody else has. You have a cell phone and you have a wallet software on it, and you download all the transactions, all the bank accounts of everybody else. So the first thing that you're going to think about is, where is my anonymity? Everybody knows how much money I have. Let's forget about that for a second. We can solve that problem, because I mean, you can have like different names with different accounts, the same thing as you have different email IDs, right? So every time I want to spend $5, every time a person A wants to, everybody, let's say Alice wants to send $5 to Bob. She only sends a message 5 to Bob and also to the rest of the world. Does that make sense? So you propagate this number to the entire world. You're telling everybody, I'm giving $5 to this person, to everybody else. And what happens is, let's assume that everybody can confirm that you're actually the owner of that wallet. So that's the number one thing. So making sure that I'm not spending your money, right? That's the number one thing that we have to make sure. The other part is we have to make sure that you actually have $5 in your account, right? Because otherwise, just the concept of money doesn't make sense. So if we can make sure these two things happen, and everybody update their databases, now we have the bank among the entire world, right? And we don't need a server to maintain that data, and we can keep spending money, right? So this is, that's the core idea, but this is very, very, very naive. Like, you're going to see like what kind of problems we're going to have with this system. So so there are two things basically. So we have to make sure we have to engineer these two criteria. So the first one is a simple message authentication, that you can basically sign documents online. So it's called, there's a technique called digital signature that has been around way before the Bitcoin comes up. So you have a piece of, so digital signature is like regular signature, but regular signature is a stupid version of the digital signature. Because if you give somebody $5 and you sign your name, that person can just cut $5 and write 10 million instead, right? And instead, you basically sign, your signature is the same for every message. That's a very stupid thing to do, because you can pay $10, like everybody can forge that for you. So the way, and when you go digital, obviously copying something is even easier than real life, right? Because it's just a series of bytes as a file that you can copy. So the way digital signature works, digital signature is function of your message. So per each message, there's a unique digital signature. And so you can ignore the first column. So you have two keys, private key and public key. You can, and there are functions called trapdoor functions in cryptography that you can sign with your private key, and everybody can open it with public key. So everybody can make sure that this is actually you, but you're the only one who can create the signature. This is actually how it works, but probably just skipping this. So going back to the scheme, we can make sure that if Alice sends $5 to us, we can authenticate Alice. That part is already done in cryptography and through digital signature. The second part, that making sure she has actually $5. Now, because everybody else knows how much everybody else has, everybody can check, right? So if she has only $10 in her account and she buys something for 20, because all the network knows that she has only 10, that transaction is invalid and everybody can reject that transaction, right? The only, so, and this has nothing to do, like so far these are very trivial things, like everybody knows this for many years. So this architecture has been around for many years, but it has one big flaw. Excuse me?
There's too much information, like, to keep track of everybody's money.
Too much, yeah, there are a lot of redundant, like, if you have, you have as many copies as your database as there are wallets in the world. Yeah, that's a concern about decentralization. But the thing is, as we go forward, the memories and the computation becomes cheaper. So that's why this is the first time that this is actually a good idea. Like this was not doable 20 years ago with the price of the memory and hard drives. Anyway, this is still, we have so these ideas, this decentralization idea, these are mostly trivial, and it has been around for many years in cryptography community. But for a specific problem, everybody in cryptography community believed that this is never going to work, and that's called double spending. Double spending is the problem that if you have $10 in your account, you can go to 100 different online stores at the same time and spend $10 at each of them. And because it takes time for the message to propagate through the network, the guy that everybody who got your message, they think, okay, I received $10 from this person. But you at the same time spend the same $10 at 100 different stores. Does that make sense? That's kind of a philosophical and very fundamental problem with the decentralized network. So one more time, it takes a message, like, any way you think about it, this is a physical process. It takes a time, even if it's 1 second, or it's 10 minutes, or it's 1 hour, it's going to take some time for the message to propagate through the network. And within that time, you can spend the money in some other places. That's the biggest problem with the decentralized banking. And that's the problem that nobody could solve it for many years. So this all happened, like this was, people were discussing about this. There are a lot of like different ideas, electronic cash, about decentralized banking, cryptography, and they all came to conclusion that you cannot solve this problem without the third. You need to have some sort of third party, some sort of management system, some sort of center in the system. There's no way that you can do it without any server or any center. Until something very interesting happens. In November 2008, there's a paper published with this name, Satoshi Nakamoto. So he claims that he's a 30-year-old Japanese guy, he lives in Japan, and he has an idea about something called Bitcoin. And he drops the paper in one cryptography forum, and he explained all the details. It's actually a very well-written paper. If you know the math and the basic cryptography, you can read it. It's very, it's actually easy to read. And he drops this paper, and basically, for people who publish papers, you know that probably when somebody looks at your paper, the first thing that they look at is your name. And if you're not famous in academia, nobody is going to even read your paper, right? And it's very crazy. This guy nobody knows his name and drops his paper, and nobody takes it seriously, obviously, for a couple of years. And he starts developing the software himself. And after a while, a few people start getting interested in this, probably some crazy people, and starts talking to him, and they form a community, and they start developing the software for Bitcoin. And it's again very crazy story. He communicates with the community for a few years through the emails. Nobody met him, and then he lives forever. Now he's not answering anybody, and he's gone. The only thing that people know from him is he still have 1 million Bitcoin, which is $3.4 billion with today's Bitcoin value. And it's very interesting. A lot of people, some people said this is like a CIA project. Some people say Putin did this. Some people say there are a lot of crazy stories. If you go to internet and search this name, there's so many. But one thing that most of people said they said he's definitely not a Japanese person. He lives in US. Some people say he's a physicist with some background in finance. It's a very interesting story. So this is the part that is actually, this is the only technical, 10 minutes of technicality. So if you don't like it, just bear 10 minutes. So this is the main part. So far we saw we can have a decentralized model, but we have a problem with double spending. How did he solve this problem? So first of all, in his proposal, I said, let's not keep track of how much money everybody has. Instead, keep track of all the transactions. And we reference every transaction, every valid transaction to all the old transactions, right? So basically, every time Alice wants to send $5 to Bob, she has to prove to the entire network that I have transactions coming to my account that they add up to more than 5, and I have not spent them. So this is what she's going to prove, and she has to show all the unspent transactions that add up to more than $5. So just to be clear, this is not blockchain. This is called transaction chain. We're going to get to the blockchain. So still we haven't solved the problem, right? So because still you can send money to somebody, you can send $5 to somebody else, it's a digital money, and you can send the same $5 to yourself at the same time, right? The person thinks, okay, I received the money, but you also send the money to yourself, right? So to solve this problem, he introduced something called blockchain, which blockchain is, this is my take. I mean, if somebody has a different opinion, you can challenge me. So I think blockchain, the people who create the blockchain are kind of like bankers, but instead of having one bank, we have millions of banks around the world. So the way it works is, you want to spend $5, you send this message to the entire world. And this is not validated, this is not confirmed. It goes to this pool. So there are a lot of, like at any point, there are like tens of thousands, hundreds of thousands unconfirmed transactions that they go to this pool, right? And every 10 minutes, somebody called a miner comes in, grabs a few thousands of these transactions, and go through them one by one, and check if these are valid transactions. By checking if these are valid transactions, I mean this money is not spent before. And if that person finds the transaction valid, it pulls them together, put them into the block, and add it to the already existing block. Every block, when a transaction is added to the block, it means that it's confirmed and validated. So why is this solving the problem? It solves maybe 50% of the problem, right? Because if you spend your money like 10 times, what's going to happen now? So this guy is going to look at like all these unconfirmed transactions. The first transaction with your name that this person sees, that transaction is going to be valid. The other 99 times is invalid. So if you go to 100 websites and you spend your money 100 times, one of them is going to be valid, 99 of them is going to be invalid. And that one is based on the time that the miners saw your transaction, not the time that you spent it. Is this right? So far there is no genius, there is no big invention here, right? He just said, okay, let's have somebody to look at this transaction, and if they're good, if they're not contradicting the existing transaction, put them into a file, put them into the block, and we call them valid transaction, and we add them to the already validated previous transactions, right? So far, nothing magical happened. You can choose which transactions you want to validate. That's you're going to see that why that's not a problem. We're still haven't seen. So you are.
So I was saying basically because you mentioned that it's about the time that when they get to the different miners, right? So what if you actually have like this chain somehow gets to the miner, and you have another transaction come in another time, and you pick the wrong one and it's actually invalid, and you actually verify that's valid because the order was missed somehow.
So what is a valid? So if you send
because of the network problems or the order is
no, but this is what happens. So you send 10 different transactions while you have only found for one of them, right? There is no notion of which one is valid or which one is invalid. At the end, one of them is valid and 9 others are invalid, right?
Yeah.
Who is going to pick which one is valid? That only depends on, it's totally random. It depends on the miner which one to pick. The thing is, if you spend your money 10 times, you're doing a fraud. And the solution for the fraud in Bitcoin architecture is you're you're validating one of them, and 9 others are. It's just a. Still, we haven't figured this. Yes.
Sure. Just step back. Figure if you use an analogy, you use banking for everybody to understand. What I'm hearing you say is that you decentralize it. Basically, you separate the ledger, right, from the actual transactions. And the miner sounds to me like you hire a bunch of accountants, and you basically give a bunch of receipts, debits, and credits, and whoever balances that ledger the fastest is the one that wins.
Yes.
Is that pretty much?
That's a good analogy. It's still like there's a huge piece of the problem that we haven't solved. So the biggest piece of the problem that we haven't solved, why should somebody mine these transactions, right? What's the incentive for that person? Why should somebody do the banking for you? And then, yes?
My question is how the system makes sure that all the unauthorized transactions after 10 minutes are covered by the miners?
They're not covered. They stay in the pool until, and there are more advanced systems, we're going to talk about it, that there's a free market that you actually tip the miner when you send a transaction. You're attaching a tip to your transaction. You're saying, okay, I'm sending $5 to this person, but I'm also attaching 25 cents to the miner. It's actually a much smaller number. But in the basic system that was the first Bitcoin proposal, there was no such a thing. And the idea was you have to flush, you have to make sure that you flush this cloud after a while, right? Your transaction might stay in the cloud for like 4, 5, 6 transactions, but the goal is to make sure it's going to flush at the end.
Because what does the miner get?
Exactly. That's still, if you think about this system, there is no genius or there is no magic here, right? We haven't. So this is where things get interesting.
Kooshiar.
Yes.
How trustworthy are these miners?
Exactly. Like we don't trust them. Why should we? I mean,
Why we should trust them?
we trust them that first of all, we trust them that they cannot create their own transaction, right? Because the validity of the transaction is based on the authentication, right? It's not based on the blockchain. We know that if a miner says these are the valid transactions, they are for sure things that somebody sent to somebody. That part is...
Now I'm trying to figure out what's the root of trust here.
We haven't solved that problem. So the thing is, yeah, you're right. A miner could be the guy who's committing the crime. He could send like $1 billion to a person, buys a company, and at the same time he sends the same $1 billion to himself, and he goes, sits here and puts that into valid block, right? So that's the problem, exactly. So how do we solve this? So we have to architecture the system to have 2 very basic criteria for these mining things to work. First of all, we have to incentivize the miners, right? They're doing some job. They're maintaining the system. They have to get paid. That's number 1. Otherwise, nobody's going to do it. Number 2 is we have to make sure that there is no one miner or a few miners that can validate most of the transactions. Because if they can do that, they become the new bank without being trustworthy at all. Like you can have like 5 random people take over the entire transaction and they can manipulate the system. Or, like, I mean, if we cannot do that, this system worth nothing. So that's the way. So this part is the basic magic of the Bitcoin paper. So he says that, okay, we want, first of all, we want to pay these people. Second, we want to make sure that a small group of people cannot do all the mining for us. How do we make sure that this is a very new topic of cryptocurrency, that he said, every time that we have this pool of transaction, we give just to simplify the matter, we give a puzzle to the entire board. This is a finding Waldo, right? This is like a simple puzzle. And ask, who can find the Waldo, right? The person, you found it? That was very fast. Like, I had a friend who found it in a second too. But that's not the goal of this system. I'll get a t-shirt. So let's say we give a really, really hard puzzle to the entire board and ask everybody to solve this at the same time. And we make sure that there's no smart way to, like this guy, there's no smart way to solve the puzzle, right? So if you think about that, if you put this puzzle for the entire room, probably different people are going to start looking at different areas, and one person is going to find it first, right? And that person gets to be the miner for the next block. And for finding Waldo, the network is going to pay him a few bitcoins, which is 12 bitcoins at the moment. So everybody starts fighting over this. So in reality, this is how it works. It's a hash function. I don't know how many people are. So hash function is basically a mathematical function that scrambles all your bytes. And it's a very well studied topic in cryptography, and this is again not an invention of this paper. So this has been around. So you give the information about the block, the information about the last blocks, the information about transaction, and a random number. And if you put this into the hash function, the answer should fall into this basically interval. And in cryptography, you prove that there is no smart way to do it. The only way to solve this problem is to try a lot of different numbers. It's the same as like finding Waldo. You have to look at like different places. And it makes sure that people can compete fairly over who is going to log the next block of transaction and who is going to win the next 12 bitcoins. So this is the magic of the paper. So it's still like there are a few problems that still like exist. For example, what if a few people can solve the problem at the same time? Who is going to get the Bitcoin? And more importantly, which block are we going to accept? Now, because we have like 2-3 different versions of database. And the answer to that question is, we're going to let people have different versions. After a while, we pick the longest version. So if somebody finds the longest chain is always the most valid. The only thing that the only big issue is what if somebody can start creating really long chain? Like if somebody has a lot of computation power and can start like building the chain. And more importantly, what if somebody can front run everybody and go solve the future blocks? So the way we built this hash function is function of already previous blocks. So nobody can front run everybody else, right? You cannot go solve the blocks for tomorrow. Because the blocks for tomorrow, this hash function is function of the today blocks also. So there is no front running. You cannot just go solve the puzzles for tomorrow. And the other assumption is so this is the biggest assumption there's a new subject, there's a new field called cryptoeconomics, that nobody has more computation power than the entire network. So the whole system is valid on if somebody can have 50% of the world computation power, the entire cryptocurrency schema being valid. But as we know, this is a claim that, for example, Google, which has like the biggest computation power among the companies, has less than 1% of the entire mining network. Yes?
So you said different people or different, let's say, miners will compete over finding to kind of solve that puzzle. And one of them who has the best answer, let's say, which is the longest string, what you're saying here, would be the winner.
At the beginning, the first person who answered the question gets to...
So it sounds kind of like they're gambling over solving this. So there is
yes,
no guarantee that
exactly.
you're going to get paid when you're putting that effort and all of the...
It's a lottery system.
Yeah. But I might be mistaken, but as far as I've heard, while you're mining, you would get paid, kind of.
Yeah.
And depending on your processing power, you would pay
exactly
a certain amount. So if that's the gambling situation, how you can say why it sounds like a sustainable amount of...
to make it sustainable, you can do the same thing that people do lottery, right? You can go with like 100 of your friends and buy lottery tickets together. That's something that people do, right? To make it more sustainable. Mm-hmm. So you're basically averaging it out. That's something that people do, and it has its own problems, but you know.
That's the same. That's the thing. Like different websites.
Yeah, you can join. You can basically submit your laptop. You can download the software, and your laptop starts joining different networks, and you basically lend your laptop or your cell phone computation power to the network, and then they mine, and you share the rewards with each other. But so just to get out of all the technicalities and just say something. So this is so the way they reward the Bitcoin every year or every once in a while, they reduce the number of Bitcoins that they reward to the
4 years
miner. 4 years. Yeah, they changed the speculation. Is yeah, you're right.
4 years.
So and they're saying at some year in 2040 they're going to stop rewarding Bitcoin. So there is going to be no inflation. And at that time, you have to start tipping the miner yourself. So it's going to be a free market.
Who's they?
It's a community behind the. So we're going to talk about this. So there's a community and there's an organization behind these networks. But at the end of the day, when it has to be a majority public consensus in order to make a change to the protocol or some major change. So nobody, no entity or no group can make any change to the network. There is no, again, it's decentralized. There is no power or there's no company behind it. You can propose some, and they have a very smart way of collecting the consensus. Like you can vote, you can propose something, you can vote for it, you can take vote for it. So these things are under discussion like all the time. Like what should be the block size? Like after how many years we should reduce this, and how many? Yes.
So I want to go one step backwards. If I have made 100 transactions, how the blocks and the system makes sure that all of my 100 transactions are covered? Because if they're not covered, it could go. I may be able to.
So as I said, your transaction goes to the pool, and they're flushing the pool randomly. It only depends on the taste of the miner. Different miner can pick up different transactions. It's their way. The only way that you can change that is by tipping the miners. So if you have like a $1 million transaction and you want to make sure that this goes through in next 10 minutes, you can add like, let's say $100 tip to your transaction.
So if I don't tip or my transaction isn't get picked by the miner, my transaction won't go through?
It depends on the network. Like it used to go through, but now because we have more transaction, actually what I heard is, this is just a technical point and it depends on how many transactions goes through the network at different time and about the network. Yeah, but you're right. Your transaction might get stuck. Yes?
So just kind of extending that, so you said every 10 minutes they come and they grab transactions to the pool. How does that like affect, like, say you want to use Bitcoin to like purchase at like a store eventually? Like
this is a, if you think about it, like if you put your credit card and you purchase, you're not confirmed until maybe 1 week after the transaction. So it's not that when you use credit card, you're getting confirmed in 1 second. You're just seeing like something on your phone. Like you can go dispute the transaction like 2 months after it happened, right? And then the thing is, this 10 minutes was a design. It was a design choice. It's not. It's an arbitrary number that the guy who built this, he probably didn't think this is going to get as big as it did. Like he just picked them. It's like it really depends on the speed of the network, and it depends on the expectation of people. There are other networks, for example, Litecoin, I think has a smaller interval. Like there are different cryptocurrencies. They have different specs, but 10 minutes is usually not that big a time.
But could that just be a problem, like if you can spend your money twice in that same 10 minutes because it hasn't been verified yet to the blockchain?
So that's the entire idea, to make sure that doesn't happen. So the miners, that's what their job is. So this is the Bitcoin price. The reason I put this slide, yes.
So who pays the miners?
The network. So you're basically, network is kind of like the central bank. You're printing 12 and a half, I think is the number, Bitcoin every 10 minutes.
Who issues?
It's a network. It's just a computer program. There's no like.
Let's say that I want to buy like 1,000 Bitcoins right now. Who issues them?
There's no issuing anymore. The only thing that is issued is those 12 new Bitcoins. Other Bitcoins are the first group of Bitcoins that the first time that the guy came up with the idea, just distribute between his networks.
It's just a convention that the network follows.
Excuse me?
I'm saying it's just, it could be just a convention that the network follows based on the original document. Right?
Yes, so basically one more time. The network is just a software. The software can print money, right? It's just like 12 new locations, 12 new pointers.
Now, I'm exchanging some real, not real, I mean like paper money to Bitcoin in the system. I'm changing something, bringing something to the system, right? I mean,
so bringing something to this is something that you have to, when you go to a website, you go to Coinbase and you buy Bitcoin, this transaction doesn't happen in Bitcoin network. This is you're out of the network. We're talking about everything that happens inside Bitcoin network. So when you want to enter the network, let's say you want to buy 100 Bitcoin today, right? So that transaction is between your bank and at some point...
All the miners have to verify that. I'm saying that who is...
Verifies what?
I mean like this transaction from the paper cash to Bitcoin. Who is...
No, you're basically creating a wallet in the system. It's an account. And then the money, the part that you pay, let's say $3,000 to the bank and you get 1 Bitcoin, that has nothing to do with the Bitcoin network.
The secondary market is kind of like stock market or something.
That part is like, this is very crucial. Like a lot of people say, why this is slow, why this website crashed, this Bitcoin got hacked. That's not Bitcoin. That's you go to Coinbase and you buy Bitcoin with dollar. That's the same as like every other financial institute. It's a US-based company. It's based in actually San Francisco. Coinbase, which is the biggest, is backed by Andreessen Horowitz. They're raising money. It's a usual company. It's like a bank. When you get your Bitcoin, which you basically buy it from somebody in the network, the same as you buy a stock or anything.
An example would be you buy gold, right? You buy gold, and gold has a value. You buy Bitcoin, Bitcoin has a value. So where do you go buy gold?
So the thing is,
right? So Coinbase is the place to go buy Bitcoin. It has nothing to do with the transaction, the blockchain, and any of that. So you're basically separating the ledger from the actual, digital cash.
Not completely clear.
Yes.
So, I mean, as far as I understand, so the Bitcoin would be generated as for I mean, as long as the miners are basically mining these Bitcoins or these blocks.
Up to some year and then after.
So,
and that's again, that is not necessary. There are other networks that they don't have that feature and still works. Like, if you have time to talk about that, but
okay, so basically the worth of each Bitcoin or this kind of currency is the fee that is being paid to the miners, or let's say
yes,
the same. They're kind of similar to what we have as accountant or as the banks here.
Yes.
I mean, the regular ones. So first of all, the first question is, so what you said about the micro transactions, we still are generating some cost here.
The cost, yeah, exactly, that's a good question. The cost is going to be...
I thought you were trying to say this system would resolve. So again, we are paying...
Yes, the system is resolving that. In going back to the first few slides, I said you're not... The biggest price that you're paying is not for maintaining the database. You're paying for the trust. You're not paying that money here. And for the first part, which is the smaller part, again, you're paying much less because now you have a network of all the computation power around the world, and there's a free market. So everybody is incentivized to log your transaction, to validate your transaction with a lower cost, unlike banks that probably, like how often they go after like bringing like transaction costs lower.
And about the cap of the Bitcoins. So first of all, what's the reason that they are putting a cap on these? And when they reach this cap, so basically this market, or if the market is growing, they don't have enough currency to handle. So they're putting also a cap on the whole market. If we want to imagine we are trying to transfer everything, all the transaction to Bitcoin. So we are getting to a limit, I think. That's
what's the issue, I think?
You're saying there is a cap to the number of the Bitcoins that is going to be in the network. And
that's again a design choice. They wanted to make it inflationary up to some point and then becomes flat. They want to make sure the network becomes sustainable, and after a while you can have it. And again, these aspects are changing, but this is probably not going to change. That's a very big part of Bitcoin. But it kind of makes sense because up to some point you want your network to get. Actually, if you go to this slide, what I was going to say is as the price of Bitcoin goes higher, the miners are more incentivized to be more active. So the more computation power comes to the network, the trust of the network goes up. There are more people, there are more miners, so the chance of the networks getting hijacked goes lower. So that as price of the Bitcoins goes higher, the networks become more secure and more trustworthy. That's the, yes.
As you disrupt the banking industry and the central banks, don't you think they're going to do something to disrupt?
That's obviously a big question. The one dominant answer to that question is this is very, very hard to block. Because as you know, like if they want to block something, they have to shut down the headquarters or they have to arrest some people. There is no people, there is no headquarters here.
And they electronically do something?
I mean, there are ways they can do it, but it's so much harder than blocking anything else because this is just distributed among like cell phones and laptops around the world. They have done. First of all, like I don't think it's not necessarily they are trying to shut down. A lot. For example, the chairman of the Fed, they asked her, Janet Yellen, they asked her, what do you think of Bitcoin? She said, this is not our issue. I'm not responsible. I'm responsible for dollar. This is all of. And yeah, a lot of bankers and central bankers definitely don't like this. The tax is going to be a huge issue. There is going to. one of the biggest problems was with there was a website called Silk Road that all the drug dealers moved to this website. You could buy like anything in that website and they shut it down. I mean, there's an argument that because this graph of all the transaction is public, although you're anonymous, it's actually easier to track the network of crime. Because now everything is, the connections are public. Your name is not public, but it's easier to track the network. So anyway, I think we have to speed up. So this is for people who want to see like what mining facility actually look like. This is a guy who has his own, we don't have a voice here, right? But this is a super loud, this guy basically bought thousands of CPU and GPU and connected to each other and started his own mining service. So this is actually like what people are asking, like what is mining? And it's a very funny thing. These facilities are super loud and they're generating a lot of pollution. And one big comment about Bitcoin is you're getting the entire world to spend as much computation as they can. And you're basically building a big bomb that's just warming up the entire world. This is there's a solution for that. There are new, so that there are other currencies that are not based on this. The whole mining mechanism here is called proof of work. You're actually proving somebody that you're doing computational work. There are other coins based off proof of stake. But let's move on from the technique. So basically what we did is we built a decentralized network. Decentralized in its true meaning. So this is the first time that somebody built a decentralized network that is actually decentralized. There's absolutely no middleman, absolutely no management, no center, no server, anything. So the pros would be we're removing that middleman, we're reducing the cost. There is no censorship because there's nobody in charge here. Nobody can censor anything. And everything is transparent because everybody has the same software on their laptop. Everybody is operating the exact same code. The code is free source, open source. So, and that brings more innovation because the Bank of America has access to the same data as a 15-year-old kid has in his garage, right? So they can build the same software if they want to build a loan service or other financial institute. They can compete. But that brings more. Bring more innovation. The cons. This system has no reversing back, if you think of it. Because every reversing back is like you call the customer service, you say, okay, this was wrong, and then they reverse it back. There is no customer service, there is no complaint, like everything is final. We have a huge computation base, and if you lose your password or a private key, you lost everything. There's nobody to call to, or that I think is given. So let's go back, like before going to Ethereum. I think it's something very, very. So the first interesting thing that happened was decentralization. We built a system that doesn't need management, and that's huge. Like everything that we do, if we run a school, we run government, we run banks, there's always a management, there's always a guy on the top. For the first time, we built a system that there is no person on the top. It's fully decentralized, and that's extremely valuable. The other very interesting that happened, like so this is kind of my take, but the concept of crypto economics became very big, but this is one of the takes that I have personally, is if you go back to the inception of money and cash, I think if somebody came to you and said, okay, give me your sandwich and I give you this piece of paper, that was a very weird proposal, right? Because the piece of paper didn't have any value. It was something that was very unfamiliar for the first time. And you didn't know why this is valuable. And maybe still we don't know. But we believed in it, and now everybody wants cash more than anything else. Now, if we look at what happened here, we're giving our trust, and the guy is giving computation power, something that didn't mean a lot before. So this is one thing. The other thing is, it actually makes sense, because if you think about, if you want to make things harder, you want to make sure that the person who controls the banking spend the most money, so she or he has to acquire the most valuable commodity of the day. So maybe one day the big buildings were big commodity and big value and source of power. Today is computation power, right? So the way the society goes, like, the most powerful people are the people who have the biggest computation power. So this, so there's a new field coming up, crypto economics, that covers this subject. So that was the end of the Bitcoin. So far what we did is we built one application for the money called Bitcoin. So there's new money called Bitcoin and this new technology called blockchain. So this is Vitalik. Yes.
What is the process for someone to actually build that mining facility and become a part of the network?
It's almost zero. You download it. You can do it on your laptop or on your cell phone. That's what people do. But the thing is, that mining facility has more power than this laptop.
There is no criteria.
No, that's yeah, that's the goal. There should not be any criteria for entering the mine. Otherwise, it will be the same as banking.
And is it profitable?
That's a very, so over the time, it used to be very profitable a few years ago because the Bitcoin was going up. A lot of people are complaining. The thing is, most of these big facilities are in China because it all comes to the price of electricity, and it's a very commoditized industry. So there's no smart way to make a lot of money. So we're going to get into that, but when people say getting into Bitcoin, there's like three things that you can get into Bitcoin. There's mining, there's buying, developing. That's what we're going to get to. That's like the biggest thing. So basically, this is a guy born in Russia, raised in Canada. He got introduced to concept of Bitcoin when he was 17 through his dad. And then at the age of 18, he introduced a new blockchain, a new set of technologies called Ethereum. And he said, if we solve money problem, which is basically a distributed database among a big network, why can't we use the same technique for everything else? Because if you think about it, everything else is the same concept. If you think of social media, if you think the way we do any financial contracts, if the way we distribute music is all the same thing. It's a big database, and there's a company that controls that database. Why can't we decentralize it over the network? So what he and his team did is started a programmable version of it. So if you think of the Bitcoin is a network with one simple contract on top of the network. The contract is, if I give you $5, you subtract, if I give you 10, you subtract 10 from my name, add 10 to your name. That's the simplest contract. He said, why can't we have more complex contract, right? So this is a very simple example. This is how Uber can run in decentralized world, right? You're at this location of A and B, you request the Uber. There is no Uber company. This goes to a network. Someone comes in, your cell phone GPS location becomes the same, and then after a while, your GPS location, both of your cell phone GPS location becomes the location that you requested, right? Very simple. It means this guy picks you up, drops you at your location. Not this money that you propose at the beginning before he comes, goes to his account. That's a more complex transaction than the first one, right? You're basically replaced the Uber company with a decentralized network. So you can, so there is no 20% fee anymore. It's just, maybe there is like, I don't know, 0.0001% for the miner, but you're not paying a company anymore. So he basically said, let's create a network. So the way the Ethereum works is, a good analogy would be App Store if there is no Apple. Let's say you can have different apps for different purposes, and everybody can come create a new app, and they all run on a trusted network. So it works a proof of stake, so there's no computation race, but we're not going to talk about how they do that. It has a new programming language called Solidity that you can write these new contracts that they're called smart contracts, and then the apps they call dApps, decentralized apps. And one cool thing is you can create your own coin. So there's Ethereum that is the base of the, if you think about it, so there's an Ether that is the base for this network, but you can create your own coin. Your coin runs on the same network, but they have their own value. Your network that is on top of Ethereum could become bigger than Ethereum itself, but they're just using the underlying network.
Do you still use Ethereum as a
no, as a currency? No.
You have your own currency.
You can do both. You can use Ethereum, or you can just open your laptop, download the Ethereum. They have an app, and you can start writing contracts and issue your coin. Like there are like thousands of coins people create. You can create your own coin, and that has become a very big thing recently. So a lot of people create different coins for different purposes, and let's go to this slide. This actually answers your question. There's a new concept called ICO, which is like IPO, but initial coin offering instead of initial public offering. When you want to start a project, you create, let's say, 1 million coin, which is worth nothing to you. And you sell like 100,000 of them at the day one to people with some price, with some like low price. The thing is that people want to buy your coin because if they think you have a good idea and this network becomes big, and then the people are going to use these coins inside the network and that becomes valuable, they're going to buy your coin. And it's called ICO, and it's become very big. So actually these are some numbers. So there was a company who raised $185 million. So those are dollars. In 5 days, they had a new idea for a new network. And this was a record that they raised $12 million in 10 minutes. A lot of people it takes more than 10 minutes for a VC to get to the office. And like, it's a very fast and like crazy world. But it's so this is actually like I put this picture to show like how crazy like things have got. So this is Dennis Rodman. I don't know how many of you know him, but he's a former basketball player. He's kind of a, can't even see him. He's a very crazy person. So he actually started a coin. He actually sponsored a coin called Potcoin, and he advertised it everywhere. And I don't know if you watch the news. He's the only American guy who meets his friend with North Korea president, and he goes meet him. And every time he has a meeting with him, which is on CNN, ABC, NBC, he puts Potcoin in the back as a sponsored content. And the last time he met with him during that 1 hour, the price of the Potcoin went up 70%. So I put this here that I kind of say like there are a lot of great things and genius things happening, but there are a lot of crazy things happening at the same time in this new world. Yes.
So if you're raising money with an ICO, how do you verify that company is actually doing what they said? Like
you don't verify.
You just hope.
Usually how it happens is they put a website and the first thing that they put is a white paper that basically they list their ideas and what their idea is, what's the mathematics behind it, and how it's going to work, and what's the plan. It's like the pitch, but it's more mathematical. And then they announce the dates, and you look at the team the same way you invested in startups. It's very similar, but there's no regulation.
You need to be an expert to do that.
Sure. But yes.
What's your thought process to determine which ones?
So it's a very, very hard thing to do, but basically you read their white paper, see actually their ideas. So the main thing is it has to be a very, very new idea. A lot of these ICOs, when you look at them, they're exactly the same as some other protocol, they just tweak like some variables. They're very, very few. If you think about decentralizing an industry, at the beginning it sounds easy, but when you design your application, almost 99.9% of the time it's not decentralized. You always have some sort, because this is how we think, you always have some server or manager somewhere in your thoughts. It's a good challenge to start thinking about decentralized application. Every time you think about it, think about, is there a point that is not removable from your service? And always you see in your design, there's some decentralization, some centralization in it. Yes?
So, I mean, there is a lot of money here, right? So
yes.
Is the people who actually put the money in Block 1 or all this, these are could be, people who actually got money illegally or something.
Exactly.
In the drugs, and they want to validate it with.
There is no legal, because legal, I don't want to say there is no legality, because if you think about legality, legality comes from a source, which is government and center. There is no government here. And the thing is, government comes in and shut down the website, which is, actually the cryptocurrency community likes that. When they shut down Silk Road, which was a drug dealing application, they loved it because it makes the network more trustworthy, and it makes it less likely that they try to shut down the whole thing. Actually, the price of Bitcoin actually usually goes up a couple of weeks after they're shutting down these illegal services. So we saw this concept of dApps, which is the same as the smart contracts, which is the same as this Ethereum universal programmable language, and we saw example for Uber. So this new services, this new organization, so one project was called Decentralized Autonomous Organization, which is basically the best of this world, right? You have an organization that runs by itself, and it's decentralized, it has no server, and it just works by itself based on some mathematic rules and regulations that you put in advance. You know what's going to happen. Everything is predicted. I mean, at least you know what you're getting at the beginning. So this is Decentralized Autonomous Organization. It's basically the name of this services. It's an organization that runs by itself. So one sample that you actually, if you go to the Ethereum website, the first sample is how to build U.S. Congress as a form of DAO, or Decentralized Autonomous Organization. How to basically replace the Congress. You can build democracy, you can build voting, and it's math instead of human decision. So let's talk about the cons of DAO. So there was actually, the DAO was actually started as a project for venture funding, and they wanted to raise $150 million for this project, for the entire decentralized autonomous, for the community to take care of this project. And then at the first minute, $50 million of this money got hacked or got stolen. And this is where it's getting very philosophical. Most of the people who invested in that $150 million and lost their money, they themselves believe that they should not get their money back, because at the beginning we said that this is a decentralized autonomous organization and it's working based on the rules that we set at the beginning. So the hacker didn't steal the money, he just used our feature. And this was a big debate for a very long time, and at the end they won. They said, yeah, we should not touch that person. Like, he actually won the money fair and square, and he's the owner of, like, they actually forked it. Some people said, no, we have to block that $50 million. But at the end they won. They said, we believe in this system, this is decentralized, this is autonomous, there is no going back, there is no reversing, and that was a feature of the service. And he used it. Some people say the consensus of the community is higher than the mass, that the community can go back and reverse. This is a big discussion on cryptocurrency. So we talked about I really like these memes. I think I'm the only one here. So we talked about the banking, we talked about how Bitcoin works and fixed that problem. We talked about Ethereum, which is this more generic blockchain for all the applications. Most of the talk was about the future. To wrap it up, like, let's talk about the things that are going to happen. First of all, is this secure? So the cryptographic function that we use in the cryptographic fundamentals that we use in Bitcoin are used everywhere else. So if some people say, what if we break the hash function? What if we break the public key? They say if we can break those, we can break every other system, every other bank. And it's funny actually, like, you hear, like, every day I hear news about, oh, Bitcoin got hacked because of this attack. The thing is, these attacks were out there for the last 30 years. Every couple of months there's a conference or a journal of cryptography, and like half of the journal is like attacks. But the attack doesn't mean the whole system is hacked. There's an attack on a piece of system and you fix it and you move forward. So, yeah. I'm wrapping it up.
Question answer.
I'll do 3 more minutes and then. Okay. So one big problem is quantum computers. Quantum computers can search the entire hash range in a linear time, in a polynomial time. So that's a huge thing. But there is no actual polynomial computer that can run on 256-bit. The biggest actually used to be 48. I saw news today that a Russian company, they made it to 51, so we don't get this. Let's go through all the ideas. So one of the biggest ideas out there is prediction market, right? Instead of having like multiple weather companies that predict the weather, let's have everybody compete on predicting the weather. And the same way we do we do betting on sports or everything else. They can bet against each other. And at the end, the person who can predict the weather better comes up top and makes more money. Right? The same thing we can do for everything. So the computation market, you can distribute your computation on this network and pay them to do your computation. This is a huge thing. This can replace the Amazon AWS, which is the biggest part of Amazon business. Content publishing is a big idea. I don't want to get it. Supply chain certification. This is a very interesting. You can program the money. You can, if you pay homeless with Bitcoin, you can program the money so you cannot use it for drugs. So that's a very interesting thing. If you buy a cell phone, you can look it up with all the money that came in to help building this. If you find out like 5 years ago somebody was working in building this part that didn't get paid enough, it's important for some people. You don't want to buy this. So music distribution is a big idea, and this is the kind of I'll give you as a just a game to think about it. So there are 2 big ideas. Basically IoT, Internet of Things, and artificial intelligence. So making everything connected, making everything smart. So if you think about a child, when the child grows up at some age, she starts talking to people, starts connecting to people. At some age, she becomes smart, she starts thinking. And then at some age, you start giving her money, and then everything changed, right? Because now she has to make more decisions, and she can become more creative, and she can do all sort of interesting things. What if you start paying your object money? Like, what if you have a network of smart fridges, and you pay your fridge? For example, if you're gone for a week, and your milk goes sour, your fridge can sell the milk to your neighbor. Or what if you can sell the energy that goes to your fridge, to your electricity to your neighbor, and then instead get back things from them? What if you go back for a week, and when you come back, not only your fridge didn't spend any money on electricity, it actually made money by trading your stuff with your neighbors. So this is something very funny. That's it. Thank you.
So thank you very much for joining us. Thank you so much, Kooshiar. Unfortunately, we ran out of time, so there's no more time for Q&A, but we'll promise we'll bring him back.
So this is, sorry. So this is my last slide. I'm actually working with Ehsan, the audience, in some new project in deep learning and visual search and fashion called Kadina. I want to promote this. And if you're in deep learning, you're a business developer with relationship to retailers, or if you're a front-end developer with iOS or JavaScript, please email me.
Does it use Bitcoin?
It's going to. No, I'm kidding. There's no Bitcoin yet. And then we have a group called House of a Startup. You can join on Facebook. We put like hackathon together. We're going to do more things with Puya and Parskody. Thank you. This was my ads, my YouTube ads.
Can you tell me what does your company do?
So I think it doesn't give me more time, especially for that. Email me and I'll be very happy to.
Okay.
What's your email?
Kooshiar at everything. Concertboom at Gmail.
Okay, and just to mention this again.
I'll put it here. So this is my first name. If you look me up, I'm at Gmail at Concertboom, which is my company.
So Kooshiar at gmail.com.
Facebook, that's actually is kind of enough.
Or Facebook at Kooshiar Azimian. Twitter? Okay, I just want to mention that this was, the purpose of this talk was to